Okay, hello. This is the review for Test 1 in Calculus, Math 1610, and usually I give the students kind of a question pool of question types that you may see on the test. So, in general, I'll go through and find problems that are similar to the ones here. And if this is the new edition of the book, so if you want to study, go in there, look at 1.1, make sure you can do these types of problems 19 to 39. So today, anyways, if you need this, take a screenshot and you'll have that. But anyways, today I want to just look over last year's test. So my test will be similar to last year's test. Obviously, I can have this question pool. I don't have to use the same types of questions. But the format will be similar length, similar difficulty. And okay, so let's go ahead and get started and take a look at last year's test. Okay, so hopefully you got a screenshot of this. And oh yeah, so how will the test go? Basically, you're going to need your webcam and your microphone. You'll log into WebEx just like we do for class, and then I'll be there basically so I can monitor you and make sure you're not using your book, going online to look up answers or what have you. Okay, so make sure you're not using the high-powered calculator. So I think maybe I said scientific only on the test, so I'll be checking that as well. I'll want to see which calculator you're using before you start, and then I'll give you your go-ahead. And then during the test, if you're doing something that looks fishy, I'll have to talk to you probably through the private chat. Okay, so I'll send you a message like, please keep your eyes on your paper, or what have you. Okay, so hopefully it'll go pretty smooth. It won't be a big deal, but that's what we're looking at next week. Okay, so anyways, let's get back here then and take a look at last year's test. You could find it in the content area of Blackboard. So this is the content. So you go to the start here is where I have the syllabus and stuff, and then there's the announcements. So this is now week 9-7. We only have one last section to go. So go through 2-5 and of course watch the video and stuff. Hopefully also you'll do this test. So where is the test? It's in the course content area. Hopefully you've already been there because that's where the delta epsilon stuff was. Okay. All right, so we're looking at test 1A from summer 2019, and it should look like this. Okay, so problem 1, find any intercepts. So review. Test 1A. Okay, so problem 1, find any intercepts. And we have this odd-looking function. Let's see if I can find where it is. X times y equals x times the square root of 49 minus x squared. Okay, so for intercepts, what are we doing? For the x-intercept, you let y equal 0 and solve. So you have 0, x times the square root of 49 minus x squared, and then you're solving this equation. So it's a radical equation. You want to square both sides. So you have x squared times 49 minus x squared. And of course you can, if you want to, factor that. So it'd be x squared times 7 minus x times 7 plus x. And then set the parts equal to 0. Don't forget the x squared part, okay? Then 7 minus x is 0, and then 7 plus x is 0. And then solve all three of those. So x is 0, x is 7, or x is negative 7. So we get 3 x-intercepts, 0, 0, 7, 0, and then negative 7, 0. Okay. Because we squared both sides, technically we're supposed to check our solutions and make sure they work, but just very quickly in my brain I can kind of see, yeah, those are both going to end up being 0. 49 minus negative 7 in parentheses squared will just be 49 minus 49. And then 49 minus positive 7 in parentheses squared will again be 49 minus 49. Both those will be 0. The other case, you have a 0 times the square root of something, which will end up being 0. Okay, so they all work. Y-intercepts. So for the Y-intercept, you do what? You let x equals 0. Okay, so you'll have y equals 0 times the square root of 49 minus 0 squared. 0 squared is 0. Okay, so this will be 0 times square root of 49, which is 7, which of course is 0. Okay, so our y-intercept is there at 0, 0. Okay, so these are just review type problems. You know, I'll be picking one similar to what I did in my lectures. And let's look at the next one. Okay. Find the equation of the line passing through the following points. State your equation in slope-intercept form. Okay, so we have this is number 2, and we have the points -2, 3, and 4, 5, I believe. So let me look. 2, 3, 4, 5. Yep. Okay. So you need two things to pull this off. You need a slope and you need a point, right? Okay. So for slope, it's always going to be y2 minus y1. So I have 5 minus 3 all over x2 minus x1, which is 4 minus -2. Okay, so 5 minus 3 is 2. All over 4 plus 2 is 6. And that'll end up being 1/3. Okay. And you can pick either point for your point. So I'm just going to pick the first one I see. Right. Okay. Then to get the equation of the line, I need my point slope form. So you need to have that formula memorized. So I'm going y minus 3 equals 1/3 times x minus -2. Okay. Now I clean this up. The slope-intercept form is when you have y equals mx plus b. Okay, and that's what the question was asking for. So I'm gonna clean up the insides here. Negative, negative is positive. Okay, and then I'm gonna distribute. Then add the 3 to the other side. Three is the same as 9/3, getting that common denominator going. And then our solution, 1/3 x plus 11/3. Okay. And I would expect to see work. You know, one point I have to make is I need to see your work. You can't just put solutions down, otherwise I'm going to think something's up, right? Unless you're the smartest math person in the universe, odds are you need to show some work. Okay. If you're not showing work, if you're doing a lot in your head, and I've had students that do a lot in their head, you're just going to have to tell me about it, okay? And it's, you know, if this is a real class and I was in class with you, I'd probably figure it out. But because it's not a real class, you got to work with me here, okay? You got to let me know what's going on, what kind of, you know, student you are. All right, let's look at the next one. This is number 3. Evaluate the function at the given value, the independent variable, simplify the results. So I like this question because I mean, there weren't a lot of questions on this kind of idea, but I like it because it leads into where we're going. Okay. In particular, we got more work to do with slope, and it'd be called the derivative. Okay. In particular, we want to work with this formula, which looks like a slope formula, right? It's a difference of two things over two things. So you look back at our slope here. It's kind of like that, okay? It's just more high-powered. So how do I figure this out? Well, first off, you're going to plug in x plus change in x into f of x, right? So you're literally plugging that into this. And you end up with x plus change in x squared minus 3. Okay, that's all the first part of it. I box that in blue if my pen would decide to work on. Oh, there you go. Thank you. Okay, so that is this stuff, okay, which is found just by putting the x plus change in x in for x. And then I need to go minus f of x. So minus, and you have to, all of f of x has to be subtracted. So you're going to need some parentheses there. Okay, so it'd be x squared minus 3. Okay. And of course, all of that, if the red pen would work for me, thank you, is just this. Okay, so that's this thing. Okay, and then divided by the change in x. And my goal is to clean up the numerator and hopefully cancel out the denominator and just have something without the fraction. Okay? So first what I got to do is FOIL. X plus change in x times x plus change in x, right? That change in x thing is just a variable unto itself, okay? It's not like two things being multiplied together. No, it's just the name, change in x, that's it. So x times x is x squared, plus change in x times x plus change in x times x. It's two of those, 2x change in x's. And then plus change in x squared. Okay. So what do we got? X squared plus 2x change in x plus change in x squared minus 3. And then I distribute the negative on this guy. And so I have minus x squared plus 3. And you should get some cancellation resulting. All over change in x. So the 3 minus 3, those are gone. The x squared and the x squared here are gone. And you're left with 2x change in x plus change in x squared. Is that it? Yeah, okay. All over change in x, and then you can factor change in x out of the numerator. Okay. Well, you get 2x plus change in x all over change in x, and then you can remove the change in x over change in x, and you get 2x plus change in x for your final answer. Okay, so you want to simplify these guys as much as possible. And it all is going to deal, it all is with respect to this idea of slope. All right. All right, let's look at number 4. So there was oh, sorry, I didn't show you number 3 there. Hopefully you got, maybe printed it out or you're watching along. So evaluate the function at the value of the independent variable. So if I asked for the difference quotient, obviously I have to give you that formula there. The next kind, so some inverse trig stuff. So write the expression in algebraic form. We spent some time also on trig equations. Okay, you may want to review that. But let's try this one, right? So I think we're, geez, what number are we on? Number 4. Okay. So number 4, I want to rewrite this expression algebraically. So I want to get rid of all the trig stuff. And this isn't an operation that we necessarily will do here in Calc 1, but you'll end up needing it for Calc 2. So we kind of want to keep the idea alive here. Okay, and the idea is you use triangles. Okay, so you're going to draw out a triangle. Have this angle theta. It's a right triangle. And arcsine, its input is the ratio of sides of a right triangle, okay? So sine will take in, opposite over hypotenuse. So that 2x is the opposite over hypotenuse. In other words, you can rewrite it as 2x over 1, and then the opposite side on the triangle will be 2x, and the hypotenuse side will be 1. Then you use Pythagorean Theorem, right? So you go 2x squared plus 1 squared equals the third side squared, the hypotenuse squared. Whoops, did I do that wrong? Yeah, sorry. So it's 2x squared plus b squared equals 1 squared. And then I got solving for b squared equals 1 minus 2x squared is 4x squared. And then just take the square root of both sides for the answer there. So it's going to end up being b equals square root 1 minus 4x squared. Okay, so that's the third side. And then we just use that triangle to figure out the expression. So cosine is adjacent over hypotenuse, so it would be 1 minus 4x squared all over 1. Okay, and then that's it. Let's move on. You need to know the definition, the strict definition of a limit, and probably on the test will be pretty much the same fill in the blank type. So let f be defined on an open interval. So we're dealing with open intervals. That kind of stuff becomes more and more important later on in the math universe. So we need to notice that we're saying open, not closed. Open interval containing C except possibly at C, and let L be a real number. Then the statement means that for every, and then we have to fill in these blanks, for every epsilon greater than 0, there exists a delta greater than 0. So those would be those first two blanks. Okay. There exists a delta greater than 0 such that if, so it goes if, and that first blank will be the statement about x minus c. If the distance between x and c is greater than 0 but less than this delta we picked, then we need to have f of x minus L will be within epsilon of each other. Okay? Okay, so you need those exact. If you forget the greater than 0 part, you're in trouble. Okay, that's actually a different definition. That's the definition of continuity. So I'm not being picky here. It's just it is the way it is. Okay, you got to have it kind of exact. All right then. Then the other two kind of fill in the blanks are kind of like your worksheets. We'll go ahead and go through them. So number 6, fill in the blanks. So prove. Let's see if I can put them like side by side here, so it's not idiotic. Okay, we wish to find a delta such that for any epsilon greater than 0, if, and the first blank, sorry, and that first blank we're making the x minus c statement. So if the absolute value of x minus, and you get 3 from the limit there, that has to be greater than 0 but less than delta. Then the next blank is a statement about f of x, right? So f of x, which is 3x plus 1, minus L, which is 10, should be less than epsilon. Okay, so the third blank here, then we're trying to figure out what our delta needs to be. And this is where, to the side, you do some scratch work. Okay, so to the side, you wouldn't, you're not putting this part in the blanks. You would write 3x plus 1 minus 10, and then you're trying to rewrite it as x minus 3, sort of. You're back engineering it. So you get 3x minus 9, and then you can factor out the 3, so 3 times x minus 3. And you need that thing to be less than epsilon, and you can solve for x minus 3, right? So you just divide both sides by 3, and you get epsilon over 3, and that's what's going in this next blank. So you're supposing 0 less than x minus 3 is less than delta, which will equal this thing I just found in my scratch work, epsilon over 3. Okay, so now we kind of show our scratch work. So note, then it says, then you're writing 3x. This is what's filled in, 3x plus 1 minus 10, whoops, equals, and then you have a blank. So now you're just kind of simplifying stuff, right? So you rewrite that as 3x minus 9, and then that equals, that's when you factor out the 3, so that would be 3 times x minus 3, and then that, I think there's a less than symbol there, yeah, so less than, and then you replace the x minus 3 with epsilon over 3. So that would be 3 times epsilon over 3, which will equal epsilon, which is what we wanted to show. Okay, let's look at the next one then. The next one's different because it has that square stuff in it. Okay, the setup's the same though. So first our first blank, if in this case again x minus 3 is less than delta but greater than 0. Then the second blank will be f of x, which is absolute value x squared minus 4 minus 5 is less than epsilon. Okay, and then we need to do our scratch work to figure out our delta, and it's a back engineering thing, so it's x squared minus 4 minus 5. Okay, and we note that's the same as x squared minus 9, and then we can factor that, and x minus 3 times x plus 3. And because of this kind of variable expression, right, if we tried to solve for x minus 3, it wouldn't quite work. We would have epsilon over x plus 3. We can't have a variable epsilon, okay? So what I need to do then is to kind of put some restrictions on x minus 3. And in particular, I'm going to say x minus 3 has to be less than 1. And that will go into my delta statement there, where you see it has the min of something. Part of it is going to be curly bracket 1, and then comma the epsilon over whatever. Okay, so I'm working with this x minus 3. I'm saying it has to be less than 1. That's my restriction. And then we're going to just expand it and try to create the x plus 3 out of it. All right. So this is between 1 and negative 1. If I add, 6 to all three sides, then I'll have it. I'll have the x plus 3 part that I'm worried about in the epsilon expression. So I have a 5 less than x plus 3 less than 7. Okay, so if x minus 3 is less than 1, then x plus 3 is absolute value of is definitely going to be less than 7. Okay, so I can replace that x plus 3 thing with a 7. Okay, and basically my delta that I've just engineered, my delta is going to be the min of 1. Okay, that was the restriction I had to make, and epsilon all over this number I just found, 7. Okay, and that's what's going in this third blank here. It's this part is your answer there. Okay, once I get that, then it's kind of just recording everything that all my margin work. Okay, that's not going in the blanks. Okay, so it says note, and then it has absolute value x squared minus 4 minus 5 equals blank, right? And this is where I'm simplifying. This will just be x squared minus 9. And then that will equal, if we factor it, x minus 3 times x plus 3. And then we could replace that material with 7 and epsilon over 7. So x minus 3 is less, we're assuming is less than epsilon over 7. And then x plus 3 from above here is less than 7. So it'll be epsilon over 7 times 7, which of course equals, and then that part's written out for you, equals epsilon. Okay, so we needed to put that in the blank, this in the blank, and this in the blank. Okay, and then that's what we wanted to show. You can get more work with the worksheets that are online there. They're exactly the same. So there's only two kinds of proofs we're looking at. It's the kind of linear version, which is number 6, and then number 7 is kind of a quadratic type feel to it. Okay. In total, there's probably like 10 different types of these proofs floating about. You can go online if that's what you like. And if you keep taking like advanced math, you'll probably want to do that at some point. Okay. Alrighty then. The next kind then we're kind of just doing substitutions for our limits, right? Once we get past the strict definition, then it's just a matter of filling in the blanks. Okay. So we got x squared all over x squared plus 2. So you're plopping 3 in wherever you see x to evaluate the limit. And we noted in the continuity section when you can do this, it means the function's continuous. Okay, so this guy is continuous, and plug in 3, you get 9 all over 9 plus 2, which is 11. Okay, and that's the answer. Number 9, the limit as x goes to 5 pi over 2 of sine x. Okay. So where's 5 pi over 2? It's 1 pi over 2, 2, 3, 4, 5. So sine is 1 at 5 pi over 2. You use your, if you have a scientific calculator, that figure that out too. Number 10 is always a little tricky. I don't think I put one exactly like this on the test, but you do have to show work for some of these, right? I need you to tell me that you know how to evaluate an expression like this algebraically. So you're not doing a table, is what I'm saying. Okay, so anyways, when you try to do your substitution, you get 7 minus 7, which is 0. And downstairs, you'll have 49 minus 49, which is also 0. So this is one of our indeterminate forms. And the way we do these was to do some algebra. Okay, so we factor the denominator. That's x minus 7 times x plus 7. This is where it's a little tricky. It's because you can remove these factors 7 minus x and x minus 7 so long as you realize that's the same as negative 1 over 1. Okay? Those are opposite factors. Like 5 and -5 are opposites. If you add them together, you get 0. If you added 7 minus x plus x minus 7 together, you would also get 0. Okay? So they're additive opposites. In other words, they're the same as -1 if you make a ratio out of them. Okay, okay, so then I could rewrite that expression for every place other than 7 as -1 all over x plus 7. And then you could substitute in 7 to get -1 all over 14. Okay, okay, so that one's a little tricky, but I need to know that you can do these algebraic methods to evaluate limits. So if you do like just put a chart there, I know some people like to do the charts a lot, that's bad news. That tells me you didn't learn what you needed to learn. Okay, so I know you can kind of figure it out doing a chart, but please do not do that for these problems. You should know how to factor them and get your answer. Okay, I need to know that you know how to do that. That's part of the state requirements of the course. Okay, okay, so number 11 is another one of these where you have to do some algebra. Okay, so here we have x plus 4 minus square root of 4 all over x. And again, if you try to evaluate it off the top, you're going to get square root 4 minus square root 4, which is 0. Down below, if you plug in 0, you get 0. Okay, so we have to do some algebra. And the algebra this time is rationalizing the numerator, right? So you need to show that. You need to show me that you know how to do that. Okay? So I have x plus 4, square root x plus 4 plus square root of 4. Down below, x times the square root of x plus 4 plus square root of 4. Okay, FOIL out the numerator. Let me move this over a little bit so we can see it better. Okay, here we go. So square root x plus 4 to square root x plus 4 is just x plus 4. The inner and outer terms are going to be additive opposites, so they'll add to 0. And then the last terms, negative square root 4 times square root 4 will give you 4. And down below, don't multiply it out. Just leave it as is. Okay. All right. X plus 4 minus 4 then is just going to give me x. Down below, have x times the square root of x plus 4 plus square root x square root 4. Sorry. And then you can remove those factors of x, and you'll finally have a limit you can evaluate. Okay, so you have 1 all over square root x plus 4 plus square root 4. And if you plug 0 in there, you're going to get 1 over square root 4 plus square root 4. In other words, you have 2 square root 4s in the denominator. Okay, you don't have to rationalize that. Well, I guess that's silly to leave it that way, right? It's 1 over 4. Square root of 4 is 2. Okay. Next. Some trig stuff. So there were 2 trig limits you need to have memorized. Basically the limit as theta goes to 0 of sine of theta over theta is equal to 1. And then the limit as theta goes to 0 of 1 minus cosine theta over theta equals 0. Okay. So for number 12, we use that second limit that we have memorized. So here we have h as our variable. 1 minus cosine of h squared all over h. Okay, we can't just immediately presume that it's equal to 0, right? That's not true. You need to factor it and take a look at the pieces. So you have 1 minus cosine of h all over h times, I need a little more room, times 1 minus cosine of h all over 1. Okay, the limit of that first part is, yeah, that's 0. Okay, but the limit of the second part could be anything. It could be undefined, in which case we wouldn't even be able to figure out the limit. Okay? It could be something crazy. So I still need to make sure I know what that limit is. And if we do a substitution, cosine of 0 is 1, 1 minus 1 is just 0. So we can evaluate both of those limits. Okay, that's part of the limit laws. If you look back, the limit of a product. In order for the limit of a product to be the product of the limits, both limits have to exist. Okay, so we need to be a little bit careful. 0 times 0, then, is our limit, and of course that is just 0. Okay. Continuity. So usually the continuity issue is when you have division by 0, or maybe you have a piecewise function of some sort. Last year I gave them some of these division by 0 cases. Okay. So it's not going to be, a rational function is not continuous where its denominator is equal to 0. Okay. So I take the denominator, set it equal to 0, and I have x minus 6 times x plus 6 is equal to 0. And then x is equal to 6, and x is equal to negative 6 for the discontinuities. So there's 2 discontinuities. Maybe I should give my reader a heading, right? What are you doing there, buddy? I'm finding the discontinuities. Okay, then I need to identify the discontinuities as removable or non-removable. And the removable, if you can kind of factor them away. So 6 minus x all over x minus 6 times x plus 6. The part that you got from the x minus 6 part is going to be removable. This one will be removable. Okay. The one that causes kind of an asymptote after everything is said and done will be non-removable. So this guy is non-removable. Okay. So the first one would cause a hole. The second one would cause an asymptote. All right, let's look at the number 14. Again, same question. It's the same kind of function. So I have 3 all over x cubed plus 2x. And I'm looking for discontinuities, and I have to classify them. Okay, so I have x cubed plus 2x is 0. I could factor out the x, and I get x squared plus 2 equals 0. And then it looks like my only discontinuity is at 0, right? Because x squared plus 2 will never equal 0. It's always greater than or equal to 2. So my only discontinuity is at 0, and it'll be an asymptote because it's not a 0 over 0 type. So back when you looked at this x equals 6, if you plug 6 into the original expression, you would get 0 over 0, as opposed to negative 6. If you plug negative 6 into that expression, you would get 12 over 0. So when you have a 0 over 0 form, it's going to be the removable type. Okay. Otherwise, it's the non-removable. And this guy is non-removable. Okay. Okay. Let's move on to the finding limits now. We have these L over 0 type limits that we have to worry about in math. Okay, so I'm approaching one from the left side, the negative side. And when I try my substitution, I'm getting 1 all over 0. And those forms, remember, if you have a limit of something, some function, which is L over 0, it's either going to be plus or minus infinity. Okay, so that's what we're dealing with here. And to figure out if it's plus or minus, what I suggest you do is kind of test value. Okay, so first I figure out which direction I'm coming in so I don't screw up the numbers coming in from the left. And then I find my test value. Okay, so I'm thinking numbers less than -1, so -1.1. Okay, if I plug that into 1 over x plus 1, I'll have a positive 1 all over -1.1 plus 1, which will be negative. Okay, so a positive over a negative is negative, and it'll be negative infinity. Okay, let's do another. So this time I have the limit as x goes to -2 from the right, -1 all over x plus 2. Okay. Well, look at it. So again, substitute. So this time it's -1 all over -2 plus 2 is 0. So it's L over 0. It's either going to be positive or negative infinity. Okay, so here's -2. This time I'm coming in from the right. Okay, so I have my x and y's. I'm thinking numbers like negative 1.9 in that direction. So I'll have a negative all over. Negative 1.9 plus 2 is positive. So negative over positive is negative, and this will be negative infinity. Okay, number 17. Limit as x goes to 3 from the left of 2 all over x minus 3 squared. So you try a substitution, you'll get 2 over 0. You know it's either positive or negative infinity. Because the bottom is squared, it's always going to be positive over positive. In other words, I already know my answer. If you're not sure, you can still do your substitution stuff. So 3 from the left, I'm thinking stuff like 2.9 in this direction. And this will be positive over negative 0.1 squared, which will be, 0.01. It'll be positive regardless. Positive over positive is positive. Okay, number 18 is kind of the same idea, but a little different. We have the limit as x goes to 0 from the right of x minus 3 over x. Okay, so in addition to the L over 0 and 0 over 0 forms, we also had these L minus infinity forms, L plus infinity, infinity minus L. Okay, so this is L minus some sort of infinity, right? So we can, again, just extract that little part and consider what's happening there. Okay, so it's L over 0. I need to find if it's plus or minus infinity. It'll be plus infinity, right? Let's think about it. So 0 from the right, and I'm thinking of numbers like 0.1. So that will be positive over positive. In other words, it is positive infinity. So put positive infinity there. L minus infinity will be minus infinity. Okay. Let's look at number 19, and then one more, I think. Number 19, the limit as x goes to 1 from the left of 3 plus 3 over x minus 1. So again, it's L, in this case, plus some sort of infinity. So let's see what kind of infinity that is. So I'm coming into 1 from the left. Okay, so thinking numbers like 0.9. If I plug that in, I'll get a positive over a negative. So it's negative infinity. So my answer will be negative infinity. I think for the test, I also have some just kind of, let me see, comprehension questions. So there's just one or two, I think there. Let me see. So make sure you know the ways a limit can fail. So just to the side here, I may ask something along those lines. So know the ways a limit can fail to exist. Okay. And then also be familiar with and be discontinuous. Okay. So the ways a limit can fail to exist, so different left and right behavior, unbounded behavior, or oscillation. The ways a function can fail to be continuous, it's not defined at a certain point, its limit does not exist, or the limit does not equal the actual function evaluated at the point the limit is approaching. Okay, so just make sure you know that kind of stuff. Let's look at the last one on the test. So number 20, find the limit. Limit as x goes to 0 from the right of the ln of x all over x. This one is actually a different type. If you do a substitution and you kind of think about it, all right, ln is going like this as x goes to 0. So that's a negative infinity, and then we have a 0 below. If you rewrite it, limit as x goes to 0 from the right, you'll have ln of x times, 1 over x. Okay. So as x goes to 0, ln of x is going to negative infinity. As x goes to 0 from the right, 1 over x, which looks like this, is going to positive infinity. And if you remember my video on limits, you'll know a negative infinity times positive infinity is just negative infinity. Okay, right. So hopefully that helps. Make sure you go through and review my question pool. Make sure you can handle those kind of questions. Clearly, my test won't be exactly like this test. Like I said, obviously, like problems like the problem types there will all be similar, but I'll find different kinds of questions. There's different numbers, and sometimes the review questions may be a little scrambled. Okay, so hopefully we'll be good, and then I believe the test is next week. And let's see if I got it in here. 1610. I'll let you go here in a second. Let's just make sure we're on track. If you go into the start here, that gives us our course events, right? Just everything you need to know. So this week on 9.9, we'll cover 2.5, and I'll talk a little bit about the review. Then next week on Monday, we'll have test 1 in WebEx, so you'll show up at our usual time, which is 5:30, ready to take the test. So you need a scientific calculator. You'll need some scratch paper. You're not allowed to have notes. You're not allowed to have your book. You're not allowed to have any other web pages open. And you'll need your webcam and microphone. So you go on the WebEx. You basically, I'll ask you to show me your calculator, and then I'll message you and say you're good to go, and you can go ahead and start. Again, if I see you doing anything fishy, like looking at your computer a lot and then clicking, and I'm going to think, all right, this guy's surfing the web. You're not allowed to surf the web, okay? You're not allowed to be like watching my review videos or anything like that. Okay, so I'll say, hey, please keep your eyes on your paper, and hopefully life will go on. But yeah, so we'll be doing it in WebEx. You don't need ProctorU for test 1, but for test 2, you will need to reserve your time in ProctorU. So next week, hopefully when you get done with the test and you have some extra time, you can go ahead and reserve your time in ProctorU for the upcoming test 2, okay, which will be based on web-assigned material. Okay, so I'll let you go. If you have any more questions, please ask them. Okay. Okay. I'll see you in class on this week, Wednesday, and then the test is on Monday of next week. Okay. I'll see you later.